Yeah.
Yeah.
It's like very long.
All right. We ready? 6-4? Okay. So, in this lesson, we're going to do the last two groups of identities that we did not cover before spring break. They are the two groups that are on the bottom right of your sheet, the sum to product and product to sum identities. You will not have to memorize these 8 identities. They will be on your test when you get your test, along with a blank unit circle, okay? So just keep that in mind. These are ones, if you look at them, they're very, very similar to one another, so they're pretty tough to memorize. Even I have to kind of look at them when I do them. Yes?
Do we have to verify any more identities or proofs?
Oh.
Not as many. I think your test has 1 proof on it.
How about verify?
That's it. Most of the problems we're going to be doing are calculations.
I like
Okay, here we go. Yeah, some of you might need to rotate your desk a little bit. I know we're in these groups for the map testing for algebra. Okay. First thing we're going to do is prove where these two groups of identities have come from. And we're just going to prove one of each. This one is the one we'll verify first. This is one of the product to sum identities. So it gets its name because on the left side we have a product, and on the right side we have a sum or a difference. In this case, I guess it's a difference. Okay, these identities will be used exactly what they sound like for. It'll be used to turn a product into a sum or a sum into a product, just depending on what your goal is. Okay. These 4 identities, the product to sum identities, are proved using the sum and difference identities that we did earlier a few weeks ago. If you look at this guy and this guy, do you see that that's a sum and difference? A cosine and then 2 angles added or subtracted. So what we're going to do is we're going to take those 2 pieces first and expand them using the cosine, sum, and difference identities. Okay? So I'm going to bring down my 1/2, bring down my bracket, give myself a little bit of space here. I'm going to expand cosine x minus y using sum and difference. So that's cosine x, cosine y, plus sine x, sine y. Bring down my minus. Now the subtraction is going to apply to everything after it. I'm going to put a parentheses there because I'm going to have to distribute through in a minute. Now I'm expanding cosine x plus y using sum and difference identity. So that's going to be cosine x, cosine y, minus sine x, sine y. Now we're just going to simplify this. If I distribute this negative in, what's going to happen? The cosine x, cosine y's are going to cancel. Agreed? Because you'll have a positive 1 and a negative 1. So let's just go ahead and do that. So then I have 1/2, bring down my bracket, sine x, sine y. What's going to be left in the second parentheses? It'll be a minus, a negative, so a plus, another sine x, sine y. Now what can you do? Add them together. So I'll just have 2 sine x, sine y's. And then what? 1/2 and 2 cancel. So I'm left with sine x, sine y. If you had to prove any of the product to sum identities, it would look exactly like this. It would just vary a little bit depending on what sum and difference identity you were using. But the proofs are all the same. Okay? So we're only going to do one of those. Good? Okay, now using product to sum. Again, the identities I put up here, these are the same ones that are on your sheet. They are used to turn a product into a sum or difference. All right, so I have cosine 3x, cosine x. That's a product, 2 cosines. One's a triple angle, one's a single angle. And I want to write it as a sum or a difference of 2 fractions. You first want to look at what functions are being multiplied. Here I have a cosine times a cosine, which tells me I'm going to use the cosine x, cosine y identity. Whatever angle you see first, in this case a 3x, you're going to put in where you see an x in the formula. Whatever angle you see second, you're going to put in where you see a y in the formula. Those cannot change. X is always your first angle, y is always your second angle. All right, so using that identity, it's going to look like 1/2 cosine. X minus y tells me subtract these two angles. 3x minus x plus cosine again. And now I'm going to do x plus y, so that's adding my angles. 3x plus x. Now we simplify. 3x minus x, those are both part of the angle, so you can simplify it to what? 2x. What about the second cosine? Cosine of... Can you add cosine of 2x and cosine of 4x together? Those like terms.
Yeah.
They are not, because they are different angles. We cannot put them together. Now the problem said, right, is a sum or a difference of two fractions. It's not quite what this looks like. If you distribute the 1/2 through, you can make it look like two fractions, though. It'll be a cosine 2x over 2 and a cosine 4x over 2. Should you reduce the 2's and the 4's? Probably not. No, because again, they're inside the angle, so there's nothing you can do here to simplify. If those 2 and 4's were out front of the cosine, you could simplify, reduce a little bit further, but this is kind of as far as you can go with it. The goal is, in most cases, get a nice pretty number with these, it's just to write it in another form. Right? Product is a sum, or a sum is a product, depending on what we're doing. Okay, let's do one with numbers. Sine of 15 degrees, cosine of 75 degrees. So in your homework, you'll see these both in degrees and radians. If you see a radian problem and you don't like it, you can always turn it into a degree first. So here I have a sine times a cosine, which means I'm going to use this identity here, sine first, cosine second. My first angle, 15 degrees, I'm going to put in everywhere I see an x. My second angle, 75 degrees, I'm going to put in everywhere I see a y. Okay, so it's going to look like 1/2 sine, add them together, 15 plus 75, plus sine, subtract them, 15 minus 75. Ooh. Okay, 15 plus 75 gives me 90. 15 minus 75, negative 60. Now that negative 60, we're going to have to evaluate it. If it's me, I would be using the even-odd identities. Is sine even or odd? Remember? It is odd, which means what can I do with that negative? I would just bring it out in front of the sign. So just make it minus sine 60. And now both of these, you can find those answers from your unit circle. What is the sine of 90? 1. Sine, I know it's a lot of thinking the day back from break. Sine of 60, red 3 over 2. And then I can distribute my 1/2 in. 1/2 minus red 3 over 4. Can I put those together? Yeah, it doesn't say right as a sum or a difference of two fractions, which is what we have here. So if it doesn't say that, I would simplify it, combine them together further if you can. The 1/2 we can think of as a 2 over 4, right? We want to think of it with the common denominator, so this is going to simplify to 2 minus rad 3 all over 4. And then this is one you could check in your calculator. You could type the problem in, you could type your answer in, you could make sure the decimals match like we did before. Okay? So that's product to sum. Any questions? Okay, so now the second group of identities is sum to product. And again, the goal of this is to turn something that is a sum or a difference into a product, things that are multiplied. Okay, we're going to prove one of them. This is on your sheet, the second one on your sheet, cosine x minus cosine y. We are going to prove sum to product using product to sum. We're going to prove the sum to product identities using product to sum. So I'm going to deal on the right side here. I'm going to bring down my equals. I'm going to bring down my negative 2. Those are just going to kind of hang out front for the whole thing. I'm going to make a giant bracket. this guy and this guy. Everybody agree it's a product? Two signs multiplied together? Okay, so we're going to use the sine x, sine y identity that's on your sheet. This first angle, we're going to put in everywhere we see an x. The second angle, we're going to put in everywhere we see a y. With me? Okay, so again, sine x, sine y on your sheet is the one we're looking at. It's the second one down on your paper under product to sum. So 1/2, make another little bracket here. Then it's a cosine, and it's an x minus y, so I'm going to subtract those two angles. I might need a bigger parentheses to do that. We'll see. Oops. Subtracting the angles, right now I'm just going to keep them as they are, x plus y over 2 minus x minus y over 2. Okay? Minus cosine, and now I'm going to add my angles together. X plus y over 2 plus x minus y over 2. Okay, and now we're just going to simplify. Let's simplify those angles first. They have a common denominator, which means I can put them together. Be careful on this one. This negative, you can imagine, is really being applied to that whole numerator of the second fraction. So imagine kind of distributing it in. I'm going to bring my -2 down, bring my 1/2 down, bring my cosine down. If I put those together, it's going to be over 2. What's going to be in the numerator? I'm going to have an x minus x. It's going to go away. A y minus -y, so just a 2y. What about over here? This one's a little easier because it's adding. Still going to be over 2, right? I'm going to have a 2x, and then my y's cancel. Okay, and 2y over 2 and 2x over 2, those 2's are all within the angle, so you can simplify a little bit further. Make it cosine y minus cosine x. All right, we're close. What could you do next? Yep, these are multiplied. You could choose to distribute them both in individually, or you could multiply them first and then distribute in one. So either way, it's going to be 2 steps. Multiply them together first, -1 cosine y minus cosine x. And then if I distribute that -1 in, it's going to change the sign of both of those terms. So it'll be a positive cosine x, which I'm going to write it like that because that's what the other side looks like, and a negative cosine y. And that's it. And this is how you would prove any of the sum to product identities. You would expand the more complicated side using product to sum. They're all going to look very similar. Yes, Sabrina?
I have a question.
Yes. Okay.
On the way, so when you do -2 on the outside and 1/2, where did you get the 1/2 from?
The 1/2 is in the product to sum identities. If you look at they're
okay,
still
so
in there.
And then over here.
The only thing I don't love about these is that they use x's and y's a lot in the formula. There's x's and y's in the identity, and that can get a little complicated, so you just have to be careful. Okay, using them is pretty straightforward. Find the appropriate identity and plug stuff in. Again, the instructions will be pretty clear. It'll say for this one, write as a product. So you're going to use sum to product. Again, the first angle you see will be the x in the identity. The second angle you see will be the y in the identity. And notice here I have a cosine minus a cosine. So I'm using cosine x minus cosine y, that identity in your sheet. Okay. So it's going to be -2 sine. Add them up. 2x plus 4x over 2. Sine. Subtract them. 2x minus 4x over 2. Again, you can simplify inside these angles. 2x plus 4. Oh, yep. Go ahead.
I'm sorry, I'm having trouble seeing. Is that a minus, or is it how they multiply together? The original problem.
The original problem is multiply.
Yes. See, there is no problem. So it's subtract.
So, oh, I can't even see it from that corner. Yeah, you should probably move. Okay. It's subtraction. All right, 2x plus 4x over 2. 2x plus 4x is 6x over 2 gives me 3x. And then sine 2x minus 4x. Negative 2x over 2. Negative x. I can't put those signs together but because they're different angles, but I can deal with that negative again. Sine is even or odd. Odd, which means what can I do with it? Bring it out front. I would just bring it out front of the whole term. Everything's all multiplied. There's already a negative there. If I bring another negative out front, negatives are going to cancel. So I'm just left with positive 2 sine 3x sine x. And again, the goal here was to write it as a product. We've done that. There's nothing else we can simplify in the product. Okay. All right. Let's try one with numbers. This one is sine 43 degrees plus sine 17 degrees. Sine 43 plus sine 17. I have a sine plus a sine, so I'm using sine x plus sine y that I didn't need on my sheet. Okay. All right, so that is going to be 2 sine, add my angles, 43 plus 17 over 2. Cosine, subtract your angles, 43 plus 17, nope, I just said subtract and I wrote add. Why did I do that? Minus 17 over 2. Simplify, 43 plus 17, 60 over 2, 2 sine 30, cosine 43 minus 17, 26 over 2, 13. What's the sine of 30? That's on our unit circle. It is a half. 13. Is there any identity that we know that can get us to a 13? Some indifference, half. I don't think anything's going to get us a 13. It's on half of anything, it's on any angles on our unit circle that are subtracted, so we can't simplify that. Cosine 13. And then the 1/2 times the 2, cancel 1. So answer is cosine 13. Okay? Good. All right, got one more slide for you. I'll stop there. Let's say I wanted to write sine 2x plus cosine x as a product. So I want to write it as a product. What group of identities am I using? Sum to product. Do you see any sum to product identities that say a sine plus a cosine?
No, ma'am.
No. Okay. That's very official. No. They're all the same function added or subtracted if you look at all 4 of those. Sine plus a sine or a cosine minus a cosine, something like that. So if you have a sine and a cosine added or subtracted, you have to adjust a little bit. And we're going to adjust using the identities that are right next to it on your paper, the cofunction identities. You can write a sine as a cosine or a cosine as a sine using those. Now, we haven't used them a lot before because it changes the angle, but right now we don't really care if the angle changes or not. We're just going to add them or subtract them, and that's the goal. Okay? So, for example, instead of cosine x, if I use a cofunction identity, I could write that as sine of 90 degrees minus my angle, x. Okay? And yes, it changes the angle, but it at least gives me 2 sines that are added together, so now it allows me to use the sine plus sine sum to product identity. Okay? So this is the third one down on your sheet we're using. So it's going to start with 2 and a sine, and we're going to add our angles together. 2x plus 90 minus x all over 2. And then it's a cosine. I think this one's subtraction. 2x minus, I'm going to put parentheses here, 90 minus x over 2. Okay, what can I simplify? Anything? 2x and negative x are going to give me just an x plus 90 over 2. What about in the cosine? How many x's am I going to have? Imagine you've got to distribute that negative through. 3x minus 90 over 2. And then nothing really reduces in either of those, so I would just stop at that point. Okay. All right, last one. Same sort of idea here. Cosine 3 theta plus sine 5 theta. Yes?
I have a question about the first one.
Okay.
So if both of them were like, if it was like sine 2x plus cosine 2x,
Uh-huh.
could you potentially take the 2 out?
No. We're actually going to do one right now. See, there's a 3 and a 5.
Look at that. Okay, thanks.
So that'll maybe answer your question.
Yeah.
Okay. All right. So again, we have a cosine plus a sine. There's no identity that's going to work right now, so we need to change one of them. It doesn't matter which one you change. Do you guys want to change the cosine to a sine or the sine to a cosine?
Sine to cosine.
Sine to cosine. Okay. So I'll have cosine 3 theta. That guy's not going to change. Plus cosine again. And how the cofunction identities work, it's always 90 degrees minus the angle you started with. So 5 theta in this case.
Oh,
Okay.
I thought that was 1530.
Those are thetas.
Yeah.
Okay. So now I have a cosine plus a cosine, so we're going to use the first identity on your sheet. This one is 2 cosine. Add our angles together, so 3 theta plus 90 degrees minus 5 theta all over 2. And I think this is cosine again. Yep, and subtraction. Wouldn't these be fun to memorize? All right, add our angles, subtract our angles. What am I going to get in that first one? I'm going to have a negative 2 theta. So how about we just say 90 minus 2 theta over 2. And then what about the second one? I'm going to have 8 theta minus 90. I think it's minus a negative. And then both of these fractions do reduce. They're all divisible by what? 2. So I would simplify just a little bit more at the end here, make it 2 cosine 45 degrees minus theta, and then cosine again would be 4 theta minus 45. And then you've got different angles, so that's about as far as you can go with it. Okay? We'll stop there for today. Any questions?
Oh, so I have one. I just need to bring my notebook.
Okay. All right. So tomorrow we will do 3 proofs, and then that'll be the end of this lesson. If you are starting on your homework, which I would suggest you do, some of you kind of shot yourselves in the foot a little bit with homework last time around. I'm hoping you don't make the same mistake twice. You can do all the first 4 through 48 problems, which is really only 12 problems. And many of them are just simplified. Right?
It seems like there's so many.
These are due on the homework quiz day, which is the 11th. So it's going to be the same as last time test and the homework quiz the day after. There is one that was added on here, 56. The last 4 problems are the only proof problems, so don't do those ones yet. We're going to practice them tomorrow. But the first 12, okay, should be all pretty straightforward. Find the identity, use the identity stuff. Okay? That's what we did today. All right, last 15 minutes of yours. I'll do the cell phone lotto. Let me know if you need anything. Remember, homework problems are on Polaris if you want to find them. And you need your quiz.